Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. My dear students at Rital International Academy 10th grade, regarding the worksheet, I sent it to you already. I will solve the questions now. You can solve the questions by the previous video on our lesson, interference. So here, please be with me here. It is a first question. Each set of the waves below, the two waves at the left represent two waves traveling at the same time. Here I have wave one, here wave two. You ask to combine the two waves at the right. Okay. Here I have to draw. You have to draw the two waves here. So what's going to happen here? At first, we must look here at the end of each wave. You can see that here it's come from top to bottom here. So what do we call this case? And we call constructive interference. It is a constructive interference. Okay, beside that, because the waves come with these waves at the same time, from top to bottom for each case, so it's a constructive interference. Now I have to study the amplitude for each wave. At first wave I have this amplitude 1, 2. At second wave I have this amplitude 2. So I add them. 2 plus 1 equal 3 units. So it is a 3 units. So here I have to add them 3 units. How am I gonna draw it? 1, 2 here, 1, 2. So I have to count 1, 2, and now count to up 1, 2, 3. So it is here. And then 1, 2, 3, 4. 1, 2, 3, 4. And add this here. 1, 2, 3, 4. And it would be here. So now I'm going to connect between these points here. 1, here. So this is how we draw the waves in this case. This constructive interference, we just add the amplitude for each case. Okay, the second one. At first, I have this from top to bottom, from bottom to top. So what do we call this case here? We call it destructive interference. So it's destructive interference. So I'm going to subtract both waves. Here I have an amplitude equal 2. Here I have an amplitude equal 1. I could count it as a negative 1 since it's come down. So top, bottom. So I could subtract them. 2 minus 1 equal 1 unit. So now 1, 2, 1 unit. 1, 2, 3, 1, 2, 3, 4, 1 unit. 1, 2, 3, 4, and 1 unit. In this case, sorry, apologize. Now connect between points is this way. Well, this is how I draw both of them. Okay. And see, we already solved it. You are not able to draw the previous question, draw the waves here, unless you know in which type the interference we have. At A, we know that it's a constructive interference. At B, we know it's destructive interference. Okay, we end up from question 1. Now we are going to the question 2. Complete the gap in the following paragraph. When we combine two waves or more, we got what we got when we combine two waves. We get an interference where we add. Okay, what we add? Okay, this is related to the question 1. We add an amplitude for each waves. For the waves to get what we call it? A resultant waves. Okay, now here I forgot to mention that we call this a resultant wave. Resultant wave here. Resultant is a combination between two waves or more. In our case, we only studied the two waves interference, so it is a resultant waves. Okay, if two waves in phase, that means the difference between them equal 0 degree. If two waves in phase, there is no difference between both. If two waves out of phase, the waves difference is out of waves completely. This is 180 degree. I mentioned that already in previous video. What are the two conditions for light interference to occur? Be aware here in these questions. First, waves must have a constant phase difference. We already discussed these conditions on a previous video. The second one, or the most important one, which most students are mistaken about this idea, it is waves must have an equal wavelength. Okay, it is what are two conditions for light interference to occur. Okay, sometimes they are not equal. Sometimes they are not equal. We have a partial kind of interference. If they are equal, but they are out of phase, the interference are not occurring. Here, waves must have an equal wavelength. So this is the two main conditions for interference. First one, waves must have a constant phase difference. Waves must have an equal wavelength, as we saw at previous video. Yellow wave with yellow wave, red wave with red waves, we are able to see the interference in a better manner. Okay, question 4. Explain why we cannot get a light interference between two light sources with equal wavelength. I already explained this idea at the end of the video, of the previous video. Because the two sources are not dependent on each other. The two sources work. Each source works separately from others, so they are not dependent on each other. So the waves difference are not constant. If I have this source and I have this source, they both shining a red light. This is come this way and this is come this way. So they are not dependent on each other. So wave difference are not constant. It's a random wave difference. This break one of conditions for interference waves. Waves must have a constant phase difference. So it's a break one of these conditions, so it's not working. We are not able to see the interference here. Okay, my students, in this video I solved the 4 questions regarding the worksheet I sent it to you. I hope you all understand. I hope you all remain safe, unharmed. Stay at home. Thank you everyone, and goodbye.